refill, so very thirsty. But I'll make do. I don't know if today's going to be easy or medium. I'm kind of hoping for an easy because I woke up today and it's just kind of darker than usual. So I'm feeling kind of extra sleepy. So hopefully this works out. Group anagrams. All right. So given an array of strings, we're going to group anagrams together. And anagrams are apparently words that have the same letters, just in a different order. Okay, so I've seen problems like this before, and so I know one easy way to tell if strings have the same letters is to just sort them. So EAT becomes AET, TEA becomes AET, that's the same. So we know we have the same letters in the word. So if we think about that algorithm, then we're looking at going through every letter of every word. So that'll be scaled linear with the input. And on top of that, we have to sort each word, which we can assume to be log of n. N. Wait a minute. That'll be each word. So it's not n. I think we can roughly approximate this to the log of n. And then after that, we're basically going to do like a quick lookup to see if we have that key already, which is going to be constant, roughly. So we can use a hash for that sort of thing. We'll append to array, that's constant, and that's it. So this algorithm, if we just sort each word and use that as the key, add it to a hash, is going to be n times the log of n. Now, I think we could probably get that faster. I think we could do that better. It makes sense to me that we'd be able to just loop through each word, get a key for it. Using something like even like a big map would be fine. It'd be fast enough. And basically doing the same thing, but just in a single pass. So I think that we could probably do this in just straight up linear time, but I don't think that would be very much fun. I think that would be probably tedious. So I think we'll start with this, and then I don't know, see how we'll feel. Maybe we'll just kind of check the description to see. I always kind of wonder though, like if I did go the extra miles on problems like this with that, make me a better coder, help me kind of accomplish what I'm really trying to get at with this stuff, which is basically, building that muscle so I can do stuff like this really quickly without a lot of sweat. So hopefully the bigger tasks I'm freed up to kind of concentrate on, like the problem domain or whatever. So I don't know. I just always wonder about that, whether I'm using my time effectively. And I don't know the answer. So anyway, let's just go ahead and do this. So we're going to strings. I'm going to go ahead and use reduce. And we'll keep a hash of the results and a word. Okay. And before I forget, let's go ahead and drop that in there. So we'll pass in an empty hash. All right, and what we'll do is just the word is a string, not an array, so I'm going to go ahead and split it. Also constant operation, and we'll sort. And I think that will work fine in JavaScript. It's those numeric sorts you have to watch out for. I think it'll do strings by default pretty well. So we'll call this our key. So what we're going to do is basically hash at the key is equal to if the hash of the key exists, then we'll just push it. That's weird. yeah, so let's just do an old-fashioned if statement. Basically, if it already exists, then hash a key just pushes it. Okay, and JavaScript arrays are not like normal arrays, and that you kind of think of. They're definitely kind of like vectors underneath. So as far as we're concerned, we can just do that kind of stuff and not worry about what happens underneath. That does mean for things like runtimes, like, you know, depending on exactly what we're doing, whether it's sparse or not, we might end up with truly different data structures underneath. And so, you know, this kind of stuff, you know, there's some flexibility there. Even with things like the sort, like we're assuming that they're doing something smart enough to be done in worst case time of n log n. And I'm just not sure if that's the case. All right, anyway. Okay, so here we go. Hash key is going to equal an array of RW. And then we got to return that hash, which I often forget to do. And that will be it. That will return us a hash where each key is the sorted word. But that's not the shape of our output. So we do a little key here of what this looks like. It'll be like AET equals and then the list of all the words. And so what I really want to do is just get the values. And what's the easiest way to do that? I want like a map values. I don't know how to do that in JavaScript. So I'm just going to do a little experiment here. AET equals array with TE8 and 8 in it. Okay. All right, so if I look at that, is there like object.values? Oh, there is. All right. Whoa. And look at that. It looks like what we want. So we get an array of arrays. Let me try popping one more value into our X. Let's see. Call it AA. Sure, it doesn't really matter. We're just trying to make sure that we get multiple arrays out of this. And I think that we will. All right. Why do I keep doing that? I got a new mouse, by the way. It's pretty rocking. So I can drag again. And it's kind of a normal mouse. I mean, it's a nice normal mouse. It's wired. So no more BS. Anyway, that looks exactly like I want. So all we're going to do is just return. Should we just do it as a one-liner? Object.values. Okay, so you know I like to do this. What are the chances of this working first time without ever executing this before? No syntax errors, correct answer. I'm going to say 85%. This one feels particularly easy today, assuming I understand the problem correctly, which is a big assumption. What's up out there? Oh my gosh. Oh my gosh. Wow. I forgot to return. Dang it. So close. Okay, so there's my input, their input, and I believe they said the order of the output doesn't matter for this problem. And we can see it looks like we got the exact right results here. The order of your output does not matter. So I think that's it. I'm going to go ahead and submit. I just want to kind of see what other people did to get this running in constant time. In linear time, I think you're able to do that. Oh my gosh. That's terrible. This might be the worst answer I've had. Oh my gosh. So I'm guessing everybody figured out the linear solution, so. Oh boy. Let's go look at my shame. Alright, so this is like the normal kind of screen, not the challenging, the six-day challenge screen. So it gives me information a little bit different way that I'm used to kind of looking at. So faster than 11%, that's terrible. Memory usage less than 34%, also not good. Alright, let's go see. 5 lines explained. I'm interested. Let's see here. We did a one-liner. Kinda. Let's see. 2 pointers, not using a map. Okay, so that's the kind of solution I was kind of thinking. And faster than 97%. Alright. So, this Python, this is the fast one. So, I was kind of hoping to see what that looked like. But, oh my gosh, it looks like what we did, isn't it? Sorted direction, they split it, they join. Space with a sorted S, so they sort everything. Oh, do they sort all the words ahead of time and then they just kind of look it up by index? I don't really know what this means, and I don't really want to look it up. Too early for that. All right. And by alphabetical order. Okay, so seems like everyone's still doing the alphabetical trick. So that was a good trick. And that's the kind of thing, like, if you don't do problems like this and you go into an interview, they ask you a question like this, like, that's just not something that's in your normal tool belt. And so, I don't know. Doesn't seem fair, does it? If they adhere to the sort of form, they know they belong. Okay, so, I mean, this is... Oh, well, that's slick. This reads a little nicer. I don't know if it's any faster. Map key. Yeah, so that's pretty much... I don't know what it is about this syntax. I always forget about it. I'm not even sure what it's called, but that would have been a slicker way to do it. But this is basically exactly what we wrote, which is definitely not very fast. So I'm not seeing like a easy breezy but ugly solution. It's called easy breezy, so I had to look. All right, well, I'm not seeing any big, clear, linear solutions. So I don't know why. I don't know what people did to get this so much faster. Oh, here, let's look. So the first function is basically what we did. Second one, they're looping through each word. Key equals 0. Okay, so they're constructing a key linearly. So basically, they're constructing like a unique kind of string that will identify which characters. I'm not explaining that well, but basically it's going to end up with a unique key without having to sort. And they do the map trick. So this is basically doing... Why are they doing map 4? I've expected a power of 10 here. Maybe that's because there's only so many characters in the ANSI, 256. But yeah, I don't understand why 4. But anyway, that's kind of the solution I was like trying to kind of think of, is like some way to identify and categorize those generated key that's going to be the same regardless of the order of the letters. So I believe this is sufficient by getting the character code at it. And so when you add these things up together, it should keep them separate enough to generate the same key. So it's deterministic, and we good. So that's good enough for me today. I have to go, you know, pick my peaches and cherries in Animal Crossing before work. So I might be back later to continue messing around with Beam. You know, I felt bad yesterday. I realized I spent like an hour and a half looking at Beam and didn't actually change a single line of code. So I want to make that up to anyone who was watching yesterday and get back to that maybe tonight. All right. Anyway, I hope you have a good one.